name is Kevin Quach, and today I'll be deriving the equation used for solving for the equivalent resistance of simple series DC circuits. I've taken many circuit analysis courses in the past, and am currently heading a facilitated study group for circuit analysis. This derivation is going to require a basic understanding of what Ohm's law is. Shown behind me is a simple series DC circuit where we have a voltage source in series with a resistor and another resistor. So our voltage source is labeled as Vs, our first resistor labeled as R1, and our second resistor labeled as R2, with the voltage across R1 being V1 and the voltage across R2 being V2. And the current going through the entire circuit is I. The purpose of solving for the equivalent resistance is to simplify the circuit. Shown to the right is the simplified circuit where we have a voltage source in series with one resistor as opposed to the two series resistors that we had previously. Now, to derive the equation for calculating the equivalent resistance, I will discuss what Kirchhoff's voltage law is. Kirchhoff's voltage law states that the sum of the voltages in a loop are equal to 0. So starting from this point, we're going to go up this branch, and we're going to see an increase of voltage by Vs. So we have plus Vs. And now we go from this point across to this point, and we see a drop in voltage of V1. So you have minus V1. Now from this point down to this point, you see another drop in voltage of V2. Now from this point back to our starting point, there is no voltage. Now this equation gets set equal to 0. And solving the equation for Vs, we have Vs is equal to V1 plus V2. Now, Ohm's law states that a voltage is equal to a current times a resistance. In this case, all three voltages have the same current because they are in series. Now, Vs can be written as I times our equivalent resistance. So I times R eq is equal to I times R1, because V1 is equal to the current traveling through the circuit times the resistance that the current is traveling through. Now this is going to be plus V2, which is equal to I times R2. Now you can see all of the currents are the same I. And dividing by I on both sides yields Req is equal to R1 plus R2. Now you have our equation for solving for the equivalent resistance of simple DC circuits. You will be able to simplify any series circuit down to one resistor. Now this equation was derived using two resistors, but it can be used for many resistors in series, where you would just have more currents times more resistors. In each case, since they're all in series, the current will all drop out, and your equivalent resistance will simply have another resistor added on. So once again, the point of solving for an equivalent resistance is to simplify your circuit and solve for unknown quantities. Thank you.